Hi, today I'll be demonstrating the IME tool, which is included in the Drillsoft HDX Plus package. Before we begin, we must enter in a well. For this case, I am using the offshore template. I can adjust the configuration of this well in the configurations button. I can adjust the project information, the trajectory and formation information, the tubulars, the bit, the surface piping, the RCD information, and I can input my fluid type here. For this case, I'll be using the 10 pound per gallon mud. And then I can choose what kind of data I'd like to track. For this case, I'm tracking the casing pressure and casing ECD, wellhead pressure, standpipe pressure, ECD, and equivalent mud weight. I can also adjust the line color, line width, and line style in this window. Then I exit that screen, and in order to be able to run the IME, I'll have to enter information about the influx that we want the simulation to circulate. So we first must enter the depth of entry. For this case, I'm using the TD of the well, that is 7,462 feet. The reservoir pressure, and for that case I'm using 4,030. The reservoir height, I've decided to use 50, and for the permeability I'm going with 1 millidarcy. The gas gravity, I wanted to simulate a dry gas influx, so that's 0.55 standard gravity. The volume of the influx is 10 barrels, and the drainage radius is 50 feet. Once I enter this data, I can go to Tools and hit the IME button, or go through Control-I, which is a keyboard shortcut. So once I open this, I have four separate boxes here. The wellbore, which is asking for the LOT pressure, the leak-off test pressure at the shoe. So for that, we have to enter this in pounds per gallon. For that, I'm going to use something close to the ECD while we're circulating at 500 gallons per minute. So I'm using 12.1 pounds per gallon. And I'm using a reduced flow rate of 500 gallons per minute. For the RCD pressure limit, I've decided to use 800 psi. However, I am aware that this might be too low, or for some cases too high. I will be holding 150 psi back pressure while circulating and 350 psi back pressure while doing connections. I will enter 2 and 10 barrel minimum and maximum influx detection limits. This is usually defined by the company. I can leave the separator limits blank, and then I'll go to the pre-influx surface data. So I want to color the graph. I'll show the area and then show the legends explaining what each line is. And then I can adjust the maximum values and the minimum values of the X and the Y, so I can get a better visualization of our well. So for the X-min, I'm choosing my minimum pressure, which is 150. For the maximum, I'd have to go with something over 800. So let's go with 1000. And as you see, we already have some red, some orange, some yellow, and some green in our graph. So for the Y min and max, this is based on our volume. So 0 is a minimum, and then we can say 12 barrels, since our maximum influx detection limit is 10 barrels, and the software will be circulating a 10 barrel kick. We'd like to have some more information below that 10 barrels in the graph. So once we have the graph clear, we can see the green, the yellow, the orange, and the red zone. As you know, the red zone is a no-go for NPD operations, and we usually advise to switch to conventional well control procedures. The green zone is all clear, A yellow zone is a zone where we must watch, as we might be exceeding our equipment pressure between yellow and the orange zones. So once we've done this, we can hit the delete trends button so that it does not include data from previous simulations, and hit start. So if we go to the data table, we'll see that it is populating into the table. We have a 2-barrel kick that is being circulated. I've had this at maximum speed. I can slow this down to 1x, which is basically real time, or go up to the maximum speed. So our kick is being circulated out of the well. This is the 2-barrel influx. As you can see, this is actually pretty rapid. The software is capable of running the calculation pretty quickly, which is a positive thing, as this will be useful to use while drilling and adjusting the IME while drilling every certain interval, and also in case we need to update the IME due to an influx or a change in the mud type or mud weight, we can always just pull this up and adjust, rerun the IME. As you can see, this is real time as the software is running, and we're collecting data. So for the 2-barrel kick, we have a maximum wellhead pressure of 437 psi and a casing pressure of 2,524 psi. However, our casing ECD has exceeded our limit, which was 12.1, and we have 12.14, which means we must watch out for our casing ECD if we take a 2-barrel kick at a 0.965 pounds per gallon kick intensity. Then we circulated a smaller influx, a larger influx, a 6.54 barrel influx, and our maximum wellhead pressure was 365 psi, and our casing pressure was 2,452 psi. This corresponds to 11.79 pounds per gallon casing ECD, which is below our LOT at the shoe. The next influx we circulate is the 10-barrel influx. Our maximum wellhead pressure was 316 psi, our casing pressure was 2,403 psi, and the casing ECD corresponding to the 2,403 psi is 11.55 pounds per gallon, which is also within our LOT shoe limit. So once we have this information, we can go to the adjusted post-influx surface pressure graph. This adjusts our pre-influx IME, giving us more room to operate in. So basically what this says is that we can when in the pre-influx we were not able to handle anything over 7.2 barrels and about 325 psi. Anything over that, we would start having issues with surface equipment. But with post-influx, we can see that actually we have a bit more room to work with the pressure. Additional to this, we can also see the trends and how they've been affected by the gas migration, the influx migration, and the influx management. And so that is about it. And if you have any questions, please shoot us an email. Thank you.